Hey, it's Jim here from Elliott, and today in our video we're going to be looking at using a simple freeform surface to analyze a surface profile and learning about how to distribute the data over our complicated surface to get profile with partial and full constraints for your GD&T.
All right, we have a simple alignment for this mass cube. This is a Zeiss training part that's often used for curve and freeform training. We'll just add a little clearance cube here. The measurement of freeform surfaces is a very important critical part of profile analysis. The curve module is designed to create a set of nominals to which you can compare your measurement, and that's done as a one-shot deal. In the case of freeform analysis, things are a little bit different. You can build a freeform through the CAD and creating features menu. You can also build your freeforms directly through the features menu, but for this example, we'll use the creating features option. Under the point set, you can use the freeform surface. I'm going to demonstrate a few typical ways that we would create a freeform. The first is a 4-point method. Simply apply some points onto the surface. You can set a U and V value, which is going to be a grid distribution, with an edge distance value, which is an offset from outside material. Let's just use the defaults. You can see this point distribution on the surface. Don't let this fool you. This distribution is not the actual points that would necessarily be measured on the surface, but rather a set of guideways to control the probe, how it moves and collects data. We'll get to that in a minute. Let's try a different method for distributing data. 2 points. With the 2-point method, we can select a starting point and an ending point. You can choose the number of control points you want, and keep in mind, this is not the number of points that we'll be measuring. The number of lines can be set here. A distance value can now be applied. Let's use 5 millimeters. What this will do is we'll create parallel lines with the control points distributed over the length. Another method that's interesting are single points. Single points allow you to click individual targets for your control. The probe will try to follow these, much like playing connect the dots. The closer together these points are, the more control you'll have over the actual probe motion. This is very handy for getting into areas that are difficult to reach otherwise. The section tool and the 2-point tool are similar enough that we'll skip them today. The curve option would allow us to cut sections using the section creation tool here and apply freeforms over what we would normally use as a curve. This is a little bit more advanced. From faces, though, is very interesting here. When we select on the target face, we can apply a distribution. But for interest, let's set this value to 0. As you can see, some of the control targets are right on the very edge of the CAD surface. If we change this value to, let's say, 3 millimeters and distribute again, you'll see it has moved our control targets away from the edge. This is what the edge distance value is really for. Let's go with this particular measurement for our example. We've now created a freeform surface for our measurement list. The From File option allows you to use an ASCII file to control where your targets are going. This is also a very advanced method, and we'll save this for a different lesson. Now that we have this freeform surface created, let's take a look on the inside. You should always choose surfaces used, and this will identify the actual CAD entity that is deriving our nominals. The next step would be to look inside of strategy. The point set, when expanded, shows the individual control points, and these control points can be dragged around and moved. When you collapse the point set and open it, you can control the scanning methodology. As you can see here, we're scanning a point every 2 millimeters. You don't need to have as many points in a freeform as a curve, but let's set a value of 0.5 millimeter. This will give a fairly dense coverage of our surface. When we acquire this data, the only thing that we can really use it for would be an actual profile measurement. You can find this under the Form and Location and Profile option. A profile option is going to really be useful to you with either the curve or freeform option, and most people have both these days. Let's apply this to our freeform surface. If your GD&T value has a constraint of datums, you can apply the datums here. For instance, we can select the datums that we've used on our alignment today. You can perform a partial constraint like this one. You can perform a full constraint by selecting all of your datums. Or you can select no datum reference frame, which will apply a form-only fitting calculation to the surface. Inside of the results, you can set for a bilateral one result measurement, or a very popular bilateral with 2 results, which will give you a maximum and minimum deviation. These sorts of settings will allow you to get the profiles that conform to your drawing. For more information about the advanced use of Calypso, I hope that you'll continue to join us here at Elliott Machinery. And for formal training on this material, contact us at elliottmachinery.com.